Alrighty, at the top. First question, is it anything different from what we did yesterday? And this one's a little simpler because it doesn't have all those radicals and fractions. So Rich should be able to handle this. And I will walk you through the whole process one more time. And after that, we're going to move on and I'm going to do things a little bit faster. I do want you to take notice of this little guy right here. You can plug in the given x value, this 2. You can plug that in at the beginning or at the end of finding the derivative. We've been doing it at the end, mostly because I want to make sure you understand what you're finding, that you're not finding an equation of a line, you're finding a formula for finding a slope of a tangent line. But in your textbook, and I don't know how many of you guys actually go through and read the explanation in your textbook, but if you do, they take the 2 and they plug it in from the very beginning. And that's fine, you can do that as well. So if we're looking for an equation of the tangent line to the graph at this given point, here's what we want to do. We want to do the limit as h approaches 0. And everywhere I see an x, I put in x plus h. And I'm using that whole thing you're supposed to memorize that, looks like this. F at x plus h minus f at x all over h. And we just did a couple like that on the board. So everywhere I see an x, I put in x plus h minus the actual function, which is x cubed, and the whole thing is over h. This is where the algebra gets a little bit sticky. You have to cube that binomial. The answer is not x cubed plus h cubed. You're going to have to FOIL it and then turn around and multiply it again. It means x plus h times x plus h times x plus h. So, if we square it, we get x squared plus 2xh plus h squared. And then we're going to have to multiply it again by another x plus h. Rewrite the rest of the problem. And I don't know how you guys like to stay organized and do this. Where's my pen? I don't know where the other one went. But I always take everybody times x, and then I take h times everybody. So it's going to get kind of long, but that's okay. A bunch of it's going to go away in a second. So if we take everybody times x, we get x cubed plus 2x squared h plus xh squared. Now I'm going to take everybody times h. So I have plus x squared h plus 2xh squared plus h cubed. Don't forget this minus x cubed at the end. And the whole thing is over h. And surely a bunch of this stuff is going to start to sort of cancel out. So we have x cubed and minus x cubed. Does anything else cancel out? No, we can combine some things, but some of it might go away in a second anyway. We can take an h out of everybody now. So we're dividing by h, divide by h, divide by h. If I divide this by h, that becomes h squared. Divide that by h, that becomes h to the first power. Divide by h, that's now h to the first power. So now if I shove it all together, I have the limit as h approaches 0 for 2x squared, and I have another x squared, so that's 3x squareds. Then I have an xh and a 2xh, so that's 3xh. And now, oh wait, am I forgetting something? H squared. Did I get everybody? I think so. 2x squared, 3x squared, h squared. Okay, just checking. It's easy to forget stuff. And now it's completely legal to put a 0 in for h, so when I do that, f prime of x is now 3x squared. Because if you plug in 0, those terms go away. So here's our answer. Or is that our answer? No. Not the answer. Thank you, thank you, thank you. Out of habit, I put the box around it. The question says, what's the equation for the tangent line at that point? We found a formula for finding the slope of that tangent line. So we need to figure out f prime 2 when x is 2. So I'm going to take 3x squared and I'm going to plug in 2 in place of x, and I get 12. It means your slope is 12 at that point. And now I need an equation of the line. So point slope form, y minus y sub 1, which is 8, equals m, that's my slope, times x minus x sub 1, which is 2. And that's supposed to be my equation. So there's my actual answer. It says to graph f of x and the tangent line in your calculator. So grab your calculator and go to your y equals button. And for some of you, well, everybody, you're going to add 8 to both sides of this guy right here. If you want to distribute, that's fine, but I'm going to plug in the blue one into my calculator because it has to be y equals. So plug them both into your calculator, the original function and the tangent one, and then hit zoom 6 and graph it. The first one that comes in is f of x. The next one that comes in is supposed to be a line that's tangent at 2, 8. Is it? Yeah, I think if you could really scooch in, I think you'd see that that red line is tangent at 2, 8 up here. What if that line had showed up like this? Would that be tangent at 2, 8? No, you'd know that you screwed up. So your graphing calculator is pretty handy because it can kind of prove that you're on the right track. If you don't get a line tangent at that point, then you know you kind of messed up. And if you want to see, you can put LCs and trace value. If we go to 2, you can put your trace button on 2, 8, and you kind of see that's the point where we're supposed to be tangent. Okay, so that's kind of a handy thing. Use your calculator to check. All right, let's move on. Find an equation of a line that is tangent to the graph of f. We've been doing that. And, this is different, parallel to the given line. Parallel to the given line. What do we know about parallel lines and their slopes? The slopes are the same. So let's find the slope of this guy, and then that'll tell us what kind of slope we're supposed to produce here. I'm going to add y to both sides. So what slope are we looking for here? 3. So somewhere on our graph of x cubed, there's a line that's tangent to that graph that has a slope of 3, and that's what we're looking for. So first thing we got to do is find the derivative of this guy to find that formula for slope. Now we can cheat a little bit because we just did it right here. So let's save ourselves some time. We know that f prime of x is going to turn out to be 3x squared. I'm going to save us some time and just put that. And I'm going to draw a little arrow so when I get home tonight, I'll know where that came from. Okay, I need this slope formula to equal 3. That's the slope we're looking for. So let's solve. Divide both sides by 3. Square root both sides. And it looks like x is going to have 2 values. So there are 2 places on that graph where the slope is 3. So I know one of them happens at 1 comma something, and the other one happens at -1 comma something. How do you find the something? Yeah, plug it in. So we just plug it into the function. So we're going to plug it in for f at 1. Is 1 cubed, which is 1. And f at -1, which would be -1 cubed, which is -1. So at these 2 points, the tangent line has a slope of 3. Are we finished? What are we looking for? Find an equation of a line. So how many equations will we have? 2. And this isn't too bad. We already have our points and we've got our slopes. Let's just write the equations. Y minus our first y equals the slope times x minus our first x. And y minus our second y equals the slope times x minus our second x. There's our 2 equations. Any questions on anything we've done so far? Next one, find where f of x has a horizontal tangent line. What do you know about the slope of a horizontal line? It's 0. So same process, but this time they want our slope to be 0. So we have our f of x. We've got to find the derivative. So the limit as h approaches 0, everywhere I see an x, I put in x plus h. Minus the original function. So I'm going to put minus 3x squared plus 2. So we see where the plus 2 came from? I went ahead and distributed my negative all over h. So then we distribute, oh wait, no we don't. We don't distribute because first you have to FOIL. So we have 3 times x squared plus 2xh plus h squared. If you guys didn't have that memorized before, you probably do now. Distribute your 3 and let's see if we can get rid of some things. So we have 3x squared plus 6xh plus 3h squared minus 2 minus 3x squared plus 2 all over h. Positive 2 and negative 2 cancel. Negative 3x squared and positive 3x squared cancel. With what's left, I can take an h out of everybody. I will divide by h, divide by h, divide by h. So now we have the limit as h approaches 0 for 6x plus 3h. That's what I had left over. And now it is completely legal to plug a 0 in for h, because it's not going to make anything undefined. So our derivative, the formula for finding the slope, is 6x. Anybody need any explanation of what I've done so far? Am I going too fast? I can slow down. Yeah, I know Nick's good. Like, I keep taking my cues from you, and you're kind of faster than everybody else, so I better bring it back a notch. Is everybody okay? All right, we need 6x to equal 0, because that's the slope that we're supposed to find here. So, where is the slope 0? At 0. At 0 comma something, how do you get to something? Plug it in. Where do you plug it in? The original function. So f at 0 is 3 times 0 squared minus 2. So negative 2. Now, was there any way we probably knew that answer before we even started? Yeah. This little guy right here, you knew it was a parabola. You also knew that we scooted 2 units down, and then it's, you know, a little bit wider or skinnier or something. Not that it really matters, because we're only concerned with tangent lines. If we're looking for where it's tangent and creates a slope of 0, isn't there just one place where it does that? Right there. This would be tangent where it would be a slope of 0. So you kind of knew it was going to be the vertex. But we had to show it using calculus, so we did. Questions? All right, let's move on. All right, Yaron, what do the directions say?
That's the graph of the function a dash b with its derivative 1 through 4, or 1 through 4.
Good. So we've got 8 graphs here, 4 of which are f of x, and the last 4 are the derivative graphs. Now the graph of a derivative, where they're getting their points is the x value, comma, the y value is the slope of f of x at x. So the slope is the y value. The slope is the y value. All right, I'm going to write out sort of some steps or some notes kind of off to the side. Pretty soon you're not going to need to write anything. You can just tell me the answers. But because this is your notes, and I'm not going home with you to tell you how to do this, you kind of want to write this down probably. Bless you. Letter A. For letter A, as we kind of look at this graph, I need to figure out what that derivative is going to look like. Here's one great method. You can make yourself a little t-chart, but on the right-hand side, instead of a y, that's where you're going to put your slope. Now on the left, for this point, say right here, is that x value positive or negative? X value. It's negative something, so it's a negative number. And the line that's tangent to that point, or that part of the graph, is that slope positive or negative? So it's a negative slope. All right, let's keep going. This point right here, is the x value positive or negative? So we have a negative value. And what about that slope? 0. All right, let's keep going. This little guy right here, what's the x value? 0. What's the slope going to be? Positive. Let's do one more just for kicks. X value is a positive number. And what's the slope right there? 0. Using this information, you can figure out which graph it goes with. Here's what I mean by that. We're looking for negative x value, negative y value. So negative, negative. It could be 1. Let's look at the next one. Negative, negative. Could be 2. Negative, uh-oh, that went positive. I know it's not 3. And last one, negative, negative. Nope, that's positive. So it's either 1 or 2. Let's keep going. At a negative number, it hits 0. So somewhere on the left-hand side of the graph, it crosses the x-axis. 1 or 2? 2. So we already know the answer is 2. If you wanted to finish it out, you could see that at 0, it's supposed to be a positive number. So at 0, it's a positive number. You guys kind of see that? So the answer is 2. Let's do letter B. Letter B. This point right here. Is x a positive or negative number? Just some sort of negative number, right? Let's talk about this slope. The slope that's tangent to this line right here. What can you tell me about that slope as you go up and approach that peak? It's positive, and what else? Is this slope the same as that slope? And that slope? So on the negatives, for a while, the slope is constant. And then what did we talk about yesterday happens at sharp corners? It has no derivative, which means the graph is probably going to be undefined at that place. So we're going to say at the corner, wherever that is, there's something that's undefined on the graph. And it's a negative, it's on the negative side. So there's a negative, on the negative side there's a corner where it's undefined. Can you tell already what graph we're headed towards? Yeah, if we look at number 4, negative, I've got a constant, and then right here it's undefined. That's where that corner is. So already we know it's 4. And you could keep going if you wanted. You could say, you know, right at 0, where x is 0, that's a negative slope. And it's a negative constant because that slope is not going to change. It's a straight line. So you've got at 0, we've got a negative constant right there. All right, let's keep going. Letter C. Again, tonight, if you want to draw the little T-charts, awesome. If you don't and you think you can handle it without, I'm not going to make you. All right, let's look at letter C. This little guy right here, x. What do we write for x? It's a negative number of some sort. What about the slope? What's happening kind of as we get out here with the slope? It's nearing 0, so it's a tiny fraction. And is that a positive or a negative slope? Barely a negative. So I'm going to put tiny negative as my little clue. And I can tell that number, that negative number, it gets a little steeper for a while. And then right at 0, what happens? What's the slope? 0. So we have 0, 0. And then it changes to positive. So for my positive numbers, I've got a positive slope. And then for my further positive numbers, what happens? It starts to 0 out again. So tiny positive. All right, we've already used 2 and 4. So we're only looking at these 2 on the left. So negative x, tiny number, tiny negative number. Negative x, I see tiny negatives. For number 3, negative, I see huge positives. So we know the answer is 1. And you could finish it out with the graph. Obviously, what's left is 3, but you could reason it through the exact same way. Any questions? Let me ask you a question. Back over here, when we had x cubed. X cubed. The derivative wound up being something that was squared. So we went from something that was cubic to something that was quadratic. This little guy here, we had a quadratic. The derivative came up a line, a degree of 1. Alrighty, over here, I've got 1, 2 curves. So what's probably the degree of that function? 3. You add 1, so it's probably a cubic function, which means the derivative is probably a quadratic. So probably number 2. Just saying, there's a pattern there. We'll talk more about it later. Yes, sir.
So kind of the way without having to turn it out is you're just like looking at which slope matches
The y value. So you look for the slope on this guy, and that becomes your y value down here. Yes. But there is something to those curves and bumps and counting those, and degree is what it is. So, and that's going to show up more next week probably. All right, let's move on. Sketching the graph of the derivative. Sketching the graph. All right, let's talk about this. Are there places on this graph where the slope of the tangent line is going to be 0? Yeah, that's going to happen right here and right here. When x is -1 and when x is about 3.5. So if this is f of x, and this one is the derivative of f of x, 2 of the points on the derivative graph are going to be -1, 0, and 3.5, 0. On a test or an assessment or something, I would not give any leeway on either one of those. You'd have to have both of those points, for sure. The rest of it just needs to be sort of correct. But those points would have to show up, because you know for sure those points are on the graph. Does everyone see why? Okay, let's move on. For everything left of -1, what's the slope look like? They're positives, right? And it's super steep, so really big numbers. And then they sort of flatten out and get close to 0. So maybe really steep numbers and flatten out and get close to -0 for the y values?
Yeah.
Something like that? All right, for everything to the right of 3.5. I've got, some slopes that are positive, and then it gets super steep, so really big slopes. So super steep, really big slopes. In between those two, what kind of slopes are these? Those are all negatives. Now, we don't know how far negative it really goes. I mean, if you look at this, like the steepest part is probably like right there. And I don't know what that slope would be, like maybe a 4 or something. So I don't know how low this thing goes, and I'm not going to be super picky, but I do know it's negative. So what you would have to have correct to get this right on like an assessment or something is your arrows would have to be on the correct side of the x-axis, and your roots would have to be correct. Make sense? Any questions on this entire page? All right, I know it's a lot. Stay with me. Backside. This little guy here, you do not have to use this formula. We've been using the x plus h. This is another form of the derivative. It's another way to get the answer. You do kind of have to be familiar with it because of the next question. It says that the limit represents f prime of c for a function f and a number c. They want you to find the function and c is referring to an x value. And the reason we're doing this is there's a problem like this on your assignment today. So you're looking for the function and the x value. And this is not hard. There's not even any math to do. When you look at your first example, does that represent probably the new method for finding a derivative, the one you just got, or the x plus h that we've been doing? The x plus h that we've been doing. For your notes, some of you might want to actually write that right next to it so you can kind of see it. So if everywhere I saw an x, I put in x plus h, is there a part of this that looks like it's probably x plus h? Yeah, that 1 plus delta x. So this is probably the x plus h part. If this is the x plus h part, what's x? 1. So there's your c. So c equals 1. Then they wanted to know the function. Well, it'd be easy if we had minus the function, but they've got a -1 there. So it looks like they probably already plugged in the value of 1. So that's not really going to help us. We're going to have to look at this piece right here. If everywhere I saw an x, I put in x plus h, isn't this probably 2 minus 3x? So f at x equals 2 minus 3x. And that's it. That's how you do those. There's no steps to show. You just look at it and figure it out. Yes. I'm plugging in everywhere I saw an x, I put in x plus h, so I know that originally this piece right here was just x. So 2 minus 3x. Does that make sense? Okay. All right, the bottom one. Does this resemble the x plus h or probably the new guy? New guy, which is this one right here. We've got the function minus f at c. And on the bottom is x minus c. If the bottom is x minus c, what's c? 5. And now we need the function. It's supposed to be the function minus f at c. So let's just try it. If f at x really is negative x squared, I should be able to plug in a 5 and get this plus 25. If I plug in a 5, I actually get negative 25. But and I hope, well, let me write this out because some of you don't know this. Hang on. If you have negative x squared, you square the 5, and it's the opposite. It's a negative 25. But if it's this minus negative 25, that would make it a plus. So we're good. So this is the answer. It was a negative 25. That's what happened when you plug in a 5 into this. So you have the original function. According to the formula, it's minus. So minus negative 25. That makes it a plus 25. This plus is a minus a negative. So you know that that function works. Ocean, do you know how I got negative 25 in the first place? You're looking kind of... Okay. So then, if the original function was just this guy right here, and if I'm plugging in f at c, if I'm plugging in negative 25, it would be the function minus negative 25, so plus 25. That's where that came from. So it worked. You okay? Maybe? Kind of? And guys, we are out of time for this next one. I will start off with this one tomorrow. But your assignment is still page 104. Ta-da!